Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. This will be our last example of traversing a binary tree using the in-order approach or the in-order algorithm. So we always start off with our top node. So I'm going to zoom in so we can take a look at the various steps of the in-order algorithm. Now, what I'd like for you to do is to pause the video and try to do this on your own, piece of paper and pencil, and see if you can follow through the recursive calls to the function and see if you can find out and determine what the traversal numbers are that are going to be assigned to each of the different nodes. Okay, so we start off with a function call where I send you a binary tree. Here it is. If that binary tree is not empty, I am going to call recursively and send you the left subtree. So that means we go over here to the left. Here we are at this recursive call. As long as this tree is not empty, I'm going to send to you the left subtree. So that means that we're over here. I'm going to ask if you're not empty. I'm not, so I'm going to send to you the left subtree. Well, there is no left subtree, so that means now that I can visit the node. So that means that you get the number 1. All right, so the next thing to do then is to call the right, or to call the function rather, but send the right subtree. Well, that's this guy over here. So here we are at the recursive call. You are not empty. So let's start off by a recursive call and sending you the left subtree. There is no left subtree. So the next thing to do is to visit the node, which means that I assign you a number, so you're going to be number 2. All right, next I'm going to call the right. I'm going to call the in-order function, but I'm going to send to you the right subtree. There is no right subtree, so I'm done. Okay, I've exhausted all the steps for this function. Who called me? This guy did. I've exhausted all the steps for this function. Who called me? This node did. So now we're ready for its next step, which is to visit the node. So the next visitation number that's available is the number 3. All right, now let's go ahead and call the function and send the right subtree. So that means that we are over here, the right subtree. So here's our recursive call. We're going to ask the question. We are not empty. So let's go ahead and call the function with the left subtree. There is no left subtree, so we're going to visit the node. Our next visitation node is 4. All right, so then after that, let's call the function with the right subtree. That's this guy over here. All right, here is our recursive call. You are not empty. Call the left subtree. Call the function with the left subtree. There is no left subtree. So now we're going to visit the node. And so if that's the case, you are 5. I say visit the node. I should be saying visit the root, but that's really a node. Okay, next, let's go ahead and call the function with the right subtree. Well, there is no right subtree. We've exhausted all the steps for this function, so who called me? Let's go back. All right, so we were called by this guy, but we're finished with all these steps, so let's go back. All right, all of these functional steps are finished, so let's go back to whoever called us, and that's going to be this guy over here. So now we're ready to visit the root of the binary tree. Well, our last number was 5, so that means that this visit means you get designated 6. And now we're going to call the function with the right subtree, which is this part over here. All right, we're going to ask the question, are you empty? We are not. So call the function with the left subtree. There is no left subtree. So now we're ready to visit the node. If this guy is 6, then that means that this guy over here is going to get a visitation number of 7. All right, we're ready to perform the next step of our function call, which is a recursive call sending the right subtree. So we're over here. All right, so here's our recursive call. Are you empty? No. Well, if that's the case, recursive call sending you the left subtree. So over here, left. Here's our recursive call. Are you empty? No. All right, call the function recursively with the left subtree. There is no left subtree, so we visit the node. All right, so that visitation, well, the last number that I used was 7, so that means that you get the number 8. All right, the next step then is to do a recursive call with the right subtree. There is no right subtree, so we're finished with this. All right, all of these steps have been exhausted. Well, who called me? Well, this guy here did. There's still some steps to execute, namely visit the node. All right, so 8 was the last visitation number used, so that means that you get the number 9. All right, so now that I've exhausted that step, so we're going to now call the function Inorder recursively and send you the right subtree, so that means we're going over here. Here we are with our recursive call. If you're not empty, I am not empty. All right, so I'm going to send to you recursively the left subtree. There is no left subtree, so now we're going to visit the root. All right, so that means that you get the number 10, and then I execute the next recursive call, which is to send to you the right subtree. There is no right subtree. We are done with all of these, all these statements. We're done with all these because, okay, well, who called me? Well, I called you. And we're done with all those. We're done with all these. And, of course, we are done with all these. So that's the end of our program. All right, so if I zoom out, you should have gotten these traversal numbers for these particular nodes. I'm not saying that they necessarily have to be in order. I mean, that depends on if I have a sorted tree. Right now, I'm just making sure that you understand the in-order algorithm to be able to flow through what the traversal numbers would look like, and they should look like this. Now, if this tree was sorted, then notice what happens. So we got the 4 over here, 5, 6, 8, 10, 17, 19, 31, 43, and 49. So this tree was sorted, so when I go through the in-order algorithm, as you can see here, I'm able to traverse through these in order and then display those numbers one by one. But I had to follow through this algorithm recursively. And that's it. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.